Top 15 most expensive gemstones in the world. The gemstone record is more than just beauty. It is a catalog of minerals, mines, and markets, where geology and history intersect to produce the highest prices ever paid for objects extracted from the earth. In today's episode, we look at 15 stones that define the pinnacle of value, specimens certified by laboratories, traced to specific locations, and sold at prices that shape global trade. Each entry is treated as a unique case. Some have been known for centuries, entering royal coffers and museum collections. Others have only been discovered in recent decades, their reputations measured by auction catalogs rather than folklore. Together, they show that rarity is defined not by legend, but by laboratory data, provenance, and recorded transactions. The journey begins in the mines of marble, slate, basalt, and shale. From Myanmar to Madagascar, from Brazil to the Urals, these stones bear precise geological markers. Their histories are recorded in archives, the names of emperors, collectors, and auction houses. Their current value, defined by price per carat, runs into the hundreds of thousands and in some cases into the millions. This is neither a list of legends nor a survey of ordinary jewelry. This is a record of the 15 most expensive gemstones ever verified, ranked not on speculation, but on geological, historical, and market evidence. Ranked 15th, Black Opal, Australia's definitive gemological record. Opal is not a crystal. It is amorphous silica containing water, formed in voids and seams, where silica solutions settled and hardened over geological time. What makes a black opal remarkable is not its chemistry alone, but the arrangement of submicroscopic silica spheres. When those spheres align in an orderly grid, light is diffracted, breaking into visible spectral flashes. The darker the base tone of the stone, the stronger the contrast, which is why lightning-ridge black opal has become the global benchmark for the intensity of color play. On a scale from N1 to N9, only the deepest tones, N1 through N4, qualify as black. The story of Lightning Ridge is not a legend told once, but a century-long record of mining communities. Early shafts, hand-dug in the first decade of the 20th century, gave way to rudimentary hoists and later mechanical extraction. Yet much of the field remains defined by small-scale licenses, where miners still descend narrow tunnels with headlamps and hand tools. Archives from New South Wales document the fluctuating rushes, the discoveries of knobbies carrying high-grade opal, and the consolidation of a market that now serves both domestic cutting workshops and international auctions. Famous specimens are logged with precision. The Halley's Comet opal, an enormous rough discovered in 1986, was recorded not only by weight, but by face dimensions and body tone. The Aurora Australis, cut in 1938, entered the record as a polished specimen weighing 180 carats, cataloged by pattern as well as provenance. These cases set benchmarks against which subsequent finds are measured, reinforcing the ridge as the standard by which black opals are judged. Patterns are more than aesthetic. They are categories. Harlequin, with its rectangular patches aligned in nearly tessellated patterns. Flagstone, with angular blocks. Rolling flash, a band of color that travels across the surface as the stone tilts. Pinfire, a constellation of evenly sized dots. Market records show price differentials of thousands of dollars per carat between stones of the same weight but differing patterns, underscoring the role of structure and valuation. The market also insists on clarity about composition. A solid black opal is a single piece of material, natural and unassembled. Doublets and triplets, slices bonded to backing material or capped with quartz, can display striking color but are always sold with disclosure and priced accordingly. For collectors and institutions, only solid material enters the high-value tier. In export and import documentation, the distinction is explicit, and misrepresentation can lead to forfeiture of value or outright rejection at auction. Handling and preservation are part of the technical record. Black opal carries between 3 and 10% water. Sudden heating, prolonged dryness, or immersion in ultrasonic baths can create crazing, fine cracks that permanently compromise the face. For this reason, conservators recommend storing items in a stable humidity environment, cleaning with a soft cloth only, and using protective settings that shield the edges of cabochons from impact. Auction data confirms its position among the world's most valuable colored stones. High brightness, well-patterned, solid black opals from Lightning Ridge have achieved per carat values in the tens of thousands of US dollars. These figures, although below the levels of blue or pink diamonds, consistently surpass those of most other colored gems, except for ruby and cashmere sapphire. Notably, sales records include not only the carat weight and hammer price, but the exact grading descriptors, body tone, brightness, pattern, and provenance. In this sense, each sale becomes an extension of the gemological archive, binding scientific classification to commercial history. The comparative framework is clear. Light-toned opals, whether from Coober Pedy or Ethiopia, can show vivid play of color, but lack the dark backdrop that amplifies contrast. Treated stones, smoke-infused or dyed, are excluded from the same category altogether. Lightning Ridge Black Opal remains distinct for its consistent yield of high-grade solids, its long-documented chain of custody, and its entrenched grading standards developed over decades of trading. Ranked 14th, Musgravite, a case file of one of Earth's rarest gem species. Musgravite belongs to the small circle of minerals where the number of authenticated specimens can be counted in the hundreds, not thousands. Each time a laboratory certifies a faceted stone, it is logged into an international database, underscoring just how rare this species is in the market. First documented in 1967 in the Musgrave Ranges of South Australia, the stone was initially identified as Taaffeite. Both share a similar chemistry, beryllium, magnesium, and aluminum oxides, and both fall within the trigonal crystal system. Yet optical birefringence tests and X-ray diffraction establish distinctions. Musgravite contains subtle structural differences that shift its optical behavior, giving it a narrower range of pleochroic colors, often ranging from grayish-green to violet. Its hardness, between 8 and 8.5 on the Mohs scale, places it alongside Spinel and below sapphire. That durability means it could serve as a jewelry stone, but nature rarely produces clean crystals of any significant size. For decades after its recognition, gem-quality musgravite was so rare that most references existed only in mineralogical publications and museum drawers. Deposits outside Australia were later identified. Greenland's ultramafic terrains yielded microcrystalline material, while Sri Lanka produced a handful of faceable crystals. These finds confirm musgravite as a mineral with a global but minimal distribution. Still, the volume never approached commercial scale. By the late 20th century, musgravite became known within gemological circles as one of the holy grail rarities. Auction houses seldom listed it, not because of low demand, but because there was so little material available to sell. A report of a 3-carat clean stone in private hands drew international attention. Laboratories including GIA and SSEF noted that each faceted musgravite submitted for testing became part of a growing but still slim record. A tally of rarity, documented specimen by specimen. Its appeal to collectors is straightforward. The scarcity is real, measured and verifiable, not exaggerated by marketing. The mineral's value does not derive from legend or cultural lore, but from the geological fact that very few gem-quality crystals have formed, survived, and been cut. When such a stone does appear, prices exceed $35,000 per carat, placing it in the upper ranks of non-diamond-colored gems. Unlike emerald or ruby, however, musgravite lacks a public history of royal jewels or temple use. Its entire prestige lies in its academic recognition and the market's willingness to pay for a rarity defined by the record itself. Gemological publications continue to refine their profile. Reports note its refractive index range of 1.72 to 1.74, specific gravity of around 3.62, and pleochroism that varies from green to purple depending on orientation. These details matter because they distinguish musgravite from Taaffeite, with which it is so easily confused. In fact, many stones submitted as musgravite are downgraded to Taaffeite after testing, underscoring the importance of laboratory confirmation. The role of Lightning Ridge in Black Opal is cultural and commercial. The role of the Musgrave Ranges in musgravite is archival. The difference is telling. One gem built towns and trade, the other built only a line in mineralogical history. Yet for advanced collectors, that line is enough. Owning a Musgravite means holding a specimen whose identity is backed by every major laboratory, whose existence is rare enough to be documented stone by stone. Ranked 13th, Taaffeite, the gemstone discovered after it was already cut. The story of Taaffeite begins with an error. In 1945, a small oval gem, lavender pink in color, was sold as Spinel in Dublin. It passed through a dealer's hands until Count Edward Charles Richard Taaffeite examined it under magnification. Spinel is singly refractive. This stone showed double refraction. That observation forced a re-examination, and in doing so, a new mineral species was identified. Taaffeite belongs to the same oxide family as musgravite. Beryllium, magnesium, and aluminum arranged in a trigonal structure. Its hardness is between 8 and 8.5, a durability level suitable for jewelry but rarely tested in practice because gem-quality material is so uncommon. Pleochroism is distinct, with hues ranging from mauve and lilac to pink and gray-green. These shifts depend on orientation under polarized light, presenting cutters with a challenge in aligning each facet for maximum color clarity. For decades after its discovery, Sri Lanka was the only confirmed source of the substance. Placer deposits yielded occasional crystals, most of which were small, often weighing under a carat. In the latter part of the 20th century, additional sources were confirmed in Myanmar and Tanzania. Yet the supply remained minuscule. Even today, laboratories note that most stones submitted as Taaffeite turn out to be Spinel or musgravite. Precise testing is mandatory, using refractive index measurements and spectroscopic data. Unlike sapphire, emerald, or ruby, Taaffeite has no record in temples, regalia, or folklore. Its presence is strictly modern, a mineralogical entry in mid-20th century gemological literature. Yet that is precisely its importance. It represents the capacity of gemology to refine classification, separating what was long thought to be identical. What collectors value is not only the color and hardness, but the documented rarity. Only a few thousand cut stones exist in circulation, and large, clean specimens above 2 carats are seldom seen. In trade, Taaffeite is sometimes misrepresented as magnesio-Taaffeite, or confused with Spinel, leading to persistent classification challenges. Auction records are sparse, but when verified stones appear, prices can range from $20,000 to $30,000 per carat, with exceptional stones pushing beyond that threshold. Museums and advanced private collections are the usual buyers. For dealers, Taaffeite is less a commercial product and more a curiosity, an item whose very existence depends on laboratory confirmation. Documentation is central. Each stone is accompanied by laboratory reports that specify its refractive index, birefringence, pleochroism, and trace element chemistry. Without these details, a Taaffeite remains indistinguishable from its look-alike Spinel to the naked eye. In this sense, every transaction extends the record begun in 1945, another case added to a still limited file. Today, gemological institutions recognize Taaffeite as a valid species, distinct from musgravite though chemically related. The number of authenticated stones remains small, reinforcing its position among the rarest gemstones available to collectors. It is not a rarity based on myth or cultural value. It is a rarity measured by confirmed laboratory entries. Ranked 12th. Serendibite, the vanishing gem, logged in fewer than 50 stones. Serendibite entered the scientific record in 1902 when crystals collected in Sri Lanka's Ratnapur district were examined and described. The mineral was named after Serendib, the Arabic name for the island of Sri Lanka. For decades, this was a mineralogical entry without consequence for the gem trade. The known material was microscopic, often opaque, with no specimens cut into gemstones. Its structure is complex. Serendibite is a borosilicate containing calcium, magnesium, iron, aluminum, silicon, and boron. Crystallizing in the triclinic system, it appears in colors from dark green to inky black, with occasional bluish tones. Hardness ranges from 6.5 to 7 on the Mohs scale, which is lower than that of corundum, requiring careful handling in jewelry. Its refractive index is around 1.70 to 1.72, with no strong pleochroism. For much of the 20th century, Serendibite remained little more than a mineralogical curiosity. Museums recorded specimens and papers confirmed its chemistry, but the stone was absent from gemological practice. That changed when material from Myanmar proved significant and transparent enough to facet. Laboratory certificates from GIA and other institutions confirmed the identity, and for the first time, Serendibite entered the commercial record. The supply is vanishingly small. Estimates suggest fewer than 50 faceted stones of significant quality exist, most weighing under 2 carats. Each stone that surfaces is subjected to detailed testing, as other dark blue or green silicates can resemble it. Documentation includes spectroscopy, X-ray diffraction, and microprobe analysis to confirm the complete chemistry. Only then does a specimen qualify as Serendibite in gemological archives. When sold, the price reflects both rarity and provenance. Reports from the early 2000s describe stones exceeding $18,000 per carat, a figure placing it among the highest value colored gems after ruby, sapphire, and emerald. These sales did not occur in public auctions with broad publicity, but in transactions between advanced collectors, institutions, and specialized dealers. The market for Serendibite is almost invisible, existing only where laboratory reports establish certainty. Its cultural resonance lies in its name. Serendib, the island now called Sri Lanka, gave rise to the English word serendipity. Yet no evidence shows Serendibite in historical jewelry or ritual objects. It never entered temple treasuries or royal regalia. Its significance belongs instead to the modern scientific archive, a stone whose rarity is confirmed not by folklore, but by analytical instruments and catalog numbers. Gemological institutions continue to add isolated specimens to their records. Photographs of faceted Serendibite are circulated cautiously, and most collectors never see one in person. Dealers emphasize that any stone claimed as Serendibite must be accompanied by robust laboratory documentation. Without that, misidentification with Spinel or other silicates is almost guaranteed. Serendibite remains one of the rarest gemstones ever to reach the market. Its story is not one of continuous use, but of near absence. A mineral known for a century, almost forgotten, then briefly revived by discoveries in Myanmar. Unlike the major colored stones, it offers no volume for regular trade, no tradition of adornment, and no visible market cycle. It exists as an entry in records, updated only when another specimen is confirmed. Ranked 11th, Grandidierite. Grandidierite is a borosilicate mineral whose rarity is written in laboratory data. Its chemical composition, magnesium, iron, aluminum, boron, silicon, and oxygen, is arranged in the orthorhombic system. Measured values are consistent. Refractive indices around 1.58 to 1.62, birefringence near 0.020, and specific gravity just under 3. Hardness is 7.5 on the Mohs scale. Strong pleochorism is its defining optical property, with blue, green, and colorless directions seen under polarized light. These are not anecdotal traits, but recorded constants in gemological references. The mineral was first described in 1902 by Alfred Lacroix, a French mineralogist, using specimens from southern Madagascar. It was named in honor of Alfred Grandidierite, the explorer who produced comprehensive studies of Madagascar's fauna, flora, and geology. At the time of description, crystals were opaque to translucent, often massive, and not suitable for faceting. For most of the 20th century, Grandidierite existed in mineral cabinets, its name familiar to scientists but absent from jewelry. The situation changed in the early 2000s, when deposits near Tranamaro in southern Madagascar yielded transparent crystals. For the first time, gem laboratories received faceted samples. Reports from GIA and SSEF confirmed the identity, citing pleochroism that produced an unusual mix of blue-green body color. These stones, often small, became case studies in the transition of a mineral into a gemstone. The number of faceted Grandidierites remains limited. Most stones are under 2 carats, and large clean specimens are rare. Market reports confirm values exceeding $20,000 per carat for top-quality material, reflecting a combination of scarcity and the difficulty of cutting and polishing. Orientation is critical. Cutters must position the table to balance the pleochroic directions, Otherwise, the stone shows uneven patches of color. Yield is low because inclusions and fractures are standard. Culturally, Grandidierite carries no ancient associations. It is absent from historical regalia, ritual, or art. Its entire prestige lies in modern mineralogical literature and the marketplace of advanced collectors. Its entry into public awareness came not through stories of royalty, but through laboratory bulletins announcing that a previously opaque mineral now existed as a transparent gem. The gemological record is precise. Grandidierite specimens are cataloged with weight, dimensions, refractive indices, absorption spectra, and photomicrographs. Each edition expands a still-thin file. Dealers note that the majority of crystals remain unsuitable for faceting, with transparent specimens being the exceptions. The scarcity is not an artifact of marketing, but a fact of geology. Auction visibility remains low, but private sales and high-level trade have established its price bracket. Advanced collectors acquire it as part of the category of modern rarities, alongside Taaffeite and Serendibite. Institutions included in exhibits of unusual borosilicates, where its pleochroism can be demonstrated with polarizing filters. The transition from a mineral name in 1902 to a gemstone valued over $20,000 per carat more than a century later illustrates how gemology functions as a continuous record. Each specimen is not just a jewel, but an entry into the archive of recognized materials. Ranked 10th, Spinel. Spinel's history is built on error. For centuries, red spinels were passed through royal treasuries as rubies, cut into cabochons and mounted in crowns. The Black Prince's ruby in the British crown jewels is not a ruby at all, but a spinel weighing over 170 carats. The Timur ruby of the Mughal emperors shares the same story. For generations, no one questioned the identity. The correction came only when gemology advanced in the late 18th and early 19th centuries. Laboratory tools, specific gravity tests, refractive index, and optic character revealed differences. Ruby, a corundum, is doubly refractive. Spinel, a magnesium aluminum oxide, is singly refractive. Ruby belongs to the trigonal system, while spinel belongs to the cubic system. The shift from assumption to measurement reclassified entire collections. Geologically, spinel forms in metamorphic marbles and dolomitic limestones. Chromium imparts vivid red, while iron and other trace elements yield blues, purples, and pinks. With a hardness of 8, it resists wear. Yet for centuries, it was not recognized as a distinct species from corundum. Only in the modern record has spinel claimed its place. Myanmar's Mogok region produced legendary red spinels. Stones of tens and even hundreds of carats emerged, many destined for royal treasuries. These were the sources of the historic rubies that later proved otherwise. In the 21st century, a new locality transformed the perception of the gem. In 2007, miners in Tanzania's Mahenge region unearthed crystals of neon pink to vivid red spinel, highly transparent, cuttable, and unlike any seen before. Dealers and laboratories confirmed the quality, and Mahenge became a reference point for modern spinel. Culturally, spinel's lack of early recognition did not prevent it from being celebrated. Its presence in crowns and regalia across Asia and Europe means that it shaped history invisibly. Only in hindsight do inventories list these as spinels. That invisibility became its own story, centuries in ruby's shadow, only later to emerge with its proper name. The modern market has corrected the oversight. Once dismissed, spinel now stands among the most valuable colored gemstones. Burmese reds and Mahenge neon spinels, when clean and well cut, achieve prices above $50,000 per carat at the highest level. Museums and advanced collectors compete for specimens, not just for their size, but also for the vibrancy of their colors. Auction houses catalog spinel independently, no longer as a footnote to ruby. Scientific descriptors ensure the classification. Refractive index 1.718, birefringence absent, cubic symmetry. These parameters separate spinel from ruby with certainty. No longer does assumption define it, laboratory data does. The recognition of spinel parallels the evolution of gemology itself. As methods improved, identities were corrected and markets adjusted. What was once an error is now a record, and that record has restored Spinel to its own category of prestige. For centuries, red Spinels were rubies. Today, the reverse is true. The gems once celebrated as rubies are now valued precisely because they are Spinel. The error became the distinction, and the correction is what gives the stone its place at the top of the market. Ranked ninth, Paraíba Tourmaline, Brazil's neon discovery that surpassed $100,000 per carat. The story of Paraíba Tourmaline begins not in antiquity, but in the late 1980s, when miners in Brazil's Paraíba state extracted crystals that looked unlike anything the trade had seen. At first glance, they resembled tourmaline, already a known species, abundant in many colors, but under light they emitted an almost electric blue-green glow. Laboratory analysis confirmed the cause. Copper, an element not previously recognized as a chromophore in tourmaline, working in concert with manganese. These stones were albate in structure, trigonal in crystal symmetry, with a hardness of 7 to 7.5. However, the presence of copper altered their optical properties, resulting in absorption in spectra distinct from those of other tourmalines. Their refractive indices, birefringence, and pleochroism were consistent with the species, yet the color was unlike any previously documented. The impact was immediate. Within months of their debut at gem fairs and auction houses, Paraíba Tourmaline became a category of its own. Collectors and jewelers demanded them. Laboratories began to issue certificates specifying copper content, often confirmed through energy dispersive spectroscopy. Dealers emphasized provenance because Brazilian origin carried prestige. The Batalha mine, though small, entered gemological literature as the birthplace of an entirely new market phenomenon. By the early 1990s, production from the original Brazilian deposit was already limited. Prices escalated. Reports of stones over 2 carats with vivid neon saturation achieved figures previously reserved for ruby and sapphire. By the 2000s, Nigerian and Mozambican deposits had added to the supply, but laboratories continued to distinguish them from Brazilian stones. Collectors paid premiums for pieces traced directly to the state of Paraíba. Unlike ruby, emerald, or sapphire, Paraíba Tourmaline has no place in royal treasuries or historical regalia. Its reputation is built entirely on the modern record, laboratory data, auction results, and trade reports. Yet that record is formidable. Top stones have crossed the threshold of $100,000 per carat, a figure that places them in the highest echelon of colored gems. These prices reflect not only the scarcity of fine Brazilian material, but also the intensity of color saturation, a feature almost unmatched in other species. Culturally, the stone symbolizes the late 20th century's ability to redefine value. No myths, no temples, no centuries of lore, only geology, chemistry, and market dynamics. In this respect, Paraíba Tourmaline is one of the most transparent case studies in modern gemology. A discovery, an analysis, and an almost immediate escalation into global demand. Market records show a sharp divide. Commercial-grade stones are available at accessible prices, but exceptional specimens occupy a completely different category. These rare examples, with flawless clarity and neon saturation, are the ones that enter auction archives and museum holdings. Institutions note that such stones are not only scarce but also geologically unique. Copper-bearing albite from a single small mine in Paraíba, Brazil, which is now largely depleted. As laboratories continue to receive stones for testing, each certificate becomes another entry in a record that began in 1989. The rarity of origin, the chemistry of copper, and the documented escalation in value together define the gem's profile. Unlike other stones that carry centuries of history, Paraíba Tourmaline carries decades, yet it sits in the same tier of value. The file remains open. Discovered less than 40 years ago, confirmed by copper spectra, traded at over $100,000 per carat. The story of Paraíba Tourmaline stops here, mid-sentence, because its trajectory is still unfolding. Ranked 8th, Alexandrite, from Imperial Russia to a $70,000 per carat rarity. Alexandrite entered the gemological record in 1830, when miners in Russia's Ural Mountains uncovered crystals unlike chrysoberyl they had seen before. Daylight revealed a green stone, Lamplight showed a red one. Laboratory analysis later confirmed chromium as the coloring agent, its absorption bands creating a pronounced color change phenomenon. The discovery coincided with the reign of the future Tsar Alexander II, and the stone was named in his honor. The Russian Empire embraced it as a national jewel. Jewelry houses in St. Petersburg mounted Alexandrites in rings and military decorations. The dual color was noted as symbolic, green for peace, red for strength. By the mid-19th century, Alexandrite was already a rare gemstone. The Ural mines produced limited quantities, and by the early 20th century, commercial extraction declined sharply. Geologically, Alexandrite forms in mica schists and pegmatites under specific conditions, beryllium-rich fluids interacting with chromium-bearing host rocks. That conjunction is uncommon, explaining its scarcity. Its optical profile is distinct. Refractive index 1.74 to 1.75, birefringence 0.008, specific gravity 3.70 to 3.78, and hardness 8.5. Its trichroism, green, orange, and purplish red, can be observed with polarized light, but the daylight versus incandescent color change is its primary signature. As Russian production waned, Sri Lanka became the next important locality. There, Alexandrite appeared in gem gravels, but stones were typically lighter in tone, with weaker color change. Brazil later contributed specimens in the 1980s, some of which showed intense saturation. More recently, Tanzania and Madagascar have yielded stones of satisfactory quality, though production remains inconsistent. Across all sources, transparent stones over 5 carats with vivid color change are rare and highly prized. The gem's cultural role outside Russia is modest, but its scientific and collector significance is strong. Alexandrite stands as a textbook example of allochromic behavior, where trace chromium transforms a host mineral into a spectacle of shifting color. Laboratories emphasize their diagnostic spectrum, characterized by a strong absorption band in the yellow-green, which creates 2 transmission windows, one in the green and one in the red. Under different light sources, one dominates. The market reflects both fascination and scarcity. Fine Alexandrite with crisp daylight green and saturated incandescent red commands values above $70,000 per carat. Most stones trade at lower levels, but the top end establishes its place among the most expensive colored gemstones. Auction catalogs carefully describe not just carat weight, but also the percentage strength of color change, daylight hue, and incandescent hue. Laboratories such as GIA and SSEF issue detailed certificates confirming natural origin and ruling out treatments. Synthetics complicate the record. Since the mid-20th century, flux-grown synthetic Alexandrite has been available, exhibiting a substantial color change. Distinguishing natural from synthetic requires microscopic and spectroscopic examination. Advanced collectors demand reports, and untreated natural stones remain the only ones commanding high value. Today, Alexandrite's supply is fragmentary. Russian stones are virtually absent. Sri Lankan and Brazilian material provides occasional examples. African sources contribute in small numbers. Yet every confirmed stone continues a line of record stretching back to 1830. Ranked 7th, pink sapphire, Padparadscha, Sri Lanka's lotus-colored rarity above $30,000 per carat. Padparadscha sapphire exists at the intersection of 2 hues, pink and orange. Unlike blue sapphire or ruby, which are recognized by saturated primary colors, Padparadscha is defined by balance. Too much pink, and it is simply a fancy sapphire. Too much orange, and it slips into another category. Only when the two coexist in subtle harmony does the stone achieve its full potential. Geologically, Padparadscha is corundum, an aluminum oxide with a mixed hue created by chromium and iron. Its hardness of 9 makes it durable, and its trigonal crystal system yields pleochroism, sometimes showing pink in one direction, orange in another. These traits are measurable, but the definition of Padparadscha depends less on numbers than on consensus. Sri Lanka is the classic source. References to Padmaraga, lotus-colored stones, appear in early texts. Local gem cutters and dealers long recognized the color as distinct. In international trade, however, agreements have been more complex to reach. Laboratories issue certificates that define the color range, and gemological organizations publish guidelines. Yet debates persist about tone and saturation. Through the 20th century, Padparadscha remained a rarity known mainly to connoisseurs. Only in recent decades has its fame expanded, as auctions began to list certified examples. Stones above 2 carats are uncommon, and larger clean specimens command immediate attention. Auction records confirm prices above $30,000 per carat for fine unheated Sri Lankan examples. Other localities, including Madagascar and Tanzania, have produced sapphires with pink-orange hues. Some laboratories accept them under the Padparadscha definition. Others restrict the term to Sri Lankan stones. This division highlights the challenge of classification in gemology. Scientific descriptors are explicit, but trade names carry a rich history, culture, and national pride. Culturally, the Padparadscha has been associated with the lotus flower in Sri Lanka, a symbol of purity and rebirth. The stone's name itself reflects this, derived from Sanskrit and Sinhalese roots. Yet outside South Asia, its cultural role is minimal. Its significance lies primarily in the modern trade and the laboratories that arbitrate its identity. Treatment complicates the picture. Corundum can be heat-treated or diffusion-treated to alter color. Laboratories, therefore, require advanced testing, such as spectroscopy, UV fluorescence, and inclusion analysis, to confirm whether a stone is natural and unheated. Collectors pay premiums only for untreated stones with verified Padparadscha color. The market record reflects its contested status. Dealers emphasize laboratory certificates. Auction houses include precise terminology in catalogs. Collectors demand unambiguous reports, often comparing multiple lab results before bidding. Despite the debates, Padparadscha holds a secure place among the most valuable sapphires, distinguished not by volume, but by its precise and fragile balance of color. The story of the Padparadscha sapphire is therefore a record of attempts to define. Geology provides chemistry, optics, and durability. History offers a name rooted in the symbolism of the lotus. Trade provides prices that rival those of rubies and emeralds. But the actual boundary between pink sapphire, orange sapphire, and Padparadscha remains fluid. Laboratories continue to refine their guidelines, dealers continue to dispute definitions, and collectors continue to demand certificates. The debate is ongoing. There is no final sentence. Ranked 6th. Ruby Mogok's Pigeon Blood Legacy at $1.18 million per carat. Ruby has been valued for over 2,000 years, but the rubies from Mogok in central Myanmar have established the highest standard. These stones, described as pigeon blood for their saturated red with a subtle bluish undertone, became the benchmark against which all others are measured. Their chemistry is simple, corundum colored by chromium. Yet the geological conditions in Mogok created a concentration of hue and fluorescence rarely matched elsewhere. The Mogok tract consists of marble-hosted deposits where chromium-rich metamorphic environments gave rise to rubies of exceptional transparency. Inclusions of rutile, known as silk, can scatter light in ways that improve color consistency, providing depth to the red. Under sunlight, chromium fluorescence intensifies the tone, creating the vivid appearance for which Burmese rubies are known. Historical records confirm their long-standing prestige. Inscriptions and chronicles from South and Southeast Asia describe rubies as tributes delivered to rulers and as offerings to temples. Traders carried them along routes connecting Burma to India and China. By the time European traders arrived in Asia, Burmese rubies were already regarded as among the most desirable of all stones. Cultural associations reinforced their status. Burmese warriors believed rubies, if embedded under the skin, could make them invincible in battle. Kings prized them as signs of divine favor. Across Asia, ruby was associated with vitality, authority, and sacred fire. Unlike newer discoveries such as Paraíba Tourmaline, Burmese ruby carried centuries of symbolism long before modern gemology recorded its properties. In the scientific record, ruby is identified as corundum, with chromium absorption bands visible in spectroscopy, a refractive index of 1.76 to 1.77, a specific gravity of 4.0, and a hardness of 9. These constants are consistent worldwide, But only Mogok rubies consistently combine ideal tone, saturation, and fluorescence. The phrase pigeon blood is not folklore, but a trade designation refined over time to describe this unique balance. The market has validated the prestige with unprecedented prices. The most notable example is the Sunrise Ruby, a 25.59 carat Burmese ruby sold at Sotheby's Geneva in 2015 for $30.3 million. That figure, translating to over $1.18 million per carat, remains a record for ruby and one of the highest for any colored gemstone. Other sales confirm the premium. Any untreated Burmese ruby above 5 carats with intense pigeon blood color is immediately placed in the top tier of auctions. Laboratory certification is essential. Gemological institutions carefully analyze each stone to confirm its origin and verify the absence of heat treatment. Reports from SSEF, Gubaline, and GIA often accompany high-value Burmese rubies. Collectors and museums require such documentation, as even minor treatments can significantly impact the price. Modern mining conditions in Myanmar remain limited, with production constrained and political complexities affecting the supply chain. Nonetheless, the legacy of Mogok rubies is secure. Every new specimen is added to a record that spans centuries, linking present-day auctions to ancient chronicles. Ranked 5th, Colombian Emerald. Emerald has been mined in many regions, but Colombia has set the standard for what the stone should be. The mines of Muzo and Chivor in the Andean foothills yield crystals whose green is recognized worldwide. Their chemistry is chromium and vanadium-bearing beryl, with a hardness of 7.5 to 8, a refractive index of 1.577 to 1.583, and a birefringence of 0.005 to 0.009. Unlike pegmatitic beryl, Colombian emeralds formed in black shales under hydrothermal conditions, a geologic rarity that produced their unique saturation. Long before Europeans arrived, the indigenous Muisca people mined these deposits, using emeralds for ornamentation and ritual purposes. Archaeological finds confirm their use in offerings and trade. When the Spanish entered the Andes in the 16th century, they seized the mines and redirected production to Europe. From there, Colombian emeralds entered royal treasuries, cathedrals, and merchant networks. By the 17th century, Colombian origin had become a mark of distinction, embedded in inventories from Madrid to Mughal Delhi. The Muzo and Chivor mines became legendary. Records describe shipments of crystals of extraordinary transparency and size. Many Mughal jewels that survive today in museum collections feature Colombian emeralds carved into floral motifs. European regalia, including crowns and reliquaries, also incorporated these stones. Unlike ruby or sapphire, emeralds were judged not only by hue but by their depth of green, and Colombian stones consistently met that standard. Gemologically, Colombian emeralds often contain inclusions, jardin or garden, of three-phase fluid, crystals, and fissures. These inclusions confirm natural origin. Laboratories such as SSEF and GIA use advanced spectroscopy to determine origin, and Colombian emeralds often show characteristic trace element chemistry, including elevated alkali contents and specific growth features. The market distinguishes emeralds by both color and treatment. Because most emeralds are fractured, oils and resins are often used to enhance clarity. Stones without enhancement, especially of Colombian origin, command premiums. When clarity and color converge without treatment, prices reach extraordinary levels. The record is clear. In June 2017, Christie's sold the Rockefeller Emerald, an 18.04 carat Colombian stone, for $5.511 million. That figure translates to $305,000 per carat, establishing the highest documented per carat price for emerald. The stone was described as possessing exceptional color and clarity, accompanied by certificates confirming Colombian origin and minimal treatment. Auction catalogs emphasize these details as they define the stone's place in gemological history. Today, mining at Muzo and Chivor continues but yields limited top-grade material. Political, environmental, and economic factors influence supply. Despite this, Colombian emeralds remain benchmarks for quality. Stones of more than 5 carats with vivid, evenly distributed green, Transparent clarity and minimal enhancement are so rare that each one entering the market becomes part of the record. Ranked fourth, red diamond, fancy vivid rarity. Above $1 million per carat, red diamonds are crystalline carbon, cubic in structure, with a hardness of 10. Their rarity does not stem from chemistry, but rather from lattice distortion. During growth, pressure shifts and dislocations alter the crystal structure enough to create absorption bands that filter light. The result is red, the rarest stable color in diamonds. Unlike pinks, which often show modifying tones, true red is even, with no secondary hues. In the entire gemological record, fewer than 40 red diamonds have been authenticated. Most weigh less than 1 carat. Laboratories such as GIA and SSEF catalog each specimen with detailed spectroscopy, confirming that the color results from lattice distortion rather than irradiation or treatment. The rarity is geological. Only a small fraction of crystals develop the right structural deformation. The Argyle mine in Western Australia supplied the majority of known red diamonds before its closure in 2020. A few stones have been reported from Brazil and Africa, but Argyle's production defined the category. In annual Argyle tenders, any fancy red diamond was treated as an anchor lot, with intense competition among collectors. Notable examples are cataloged individually. The Argyle Phoenix, a 1.56 carat fancy red, sold in Geneva in 2013 for more than $3.2 million, establishing a per carat price above $2 million. Other Argyle reds, typically between 0.2 and 0.5 carats, have fetched equally high relative values. In 1987, the Hancock Red, a 0.95 carat fancy red, sold for $880,000, then a record $926,000 per carat, which at the time shocked the diamond market. Unlike rubies or emeralds, red diamonds lack the ancient associations of their counterparts. Their entire cultural weight comes from the modern market. Auction catalogs describe them clinically: weight, color grade, and laboratory certificate. Collectors pursue them not for lore, but for rarity, measured in the count of known stones. Scientific constants anchor the record. Refractive index, 2.42. Specific gravity, 3.52. Dispersion, 0.044. Hardness, 10. These figures are identical to all diamonds. What separates red is the lattice distortion. This structural anomaly cannot be induced predictably, making natural fancy red diamonds virtually irreplicable in quantity. The market recognizes that reality. Prices have surpassed $1 million per carat, a level shared by only a few colored diamonds, blue, pink, and red. The difference is scale. While thousands of blue and pink diamonds exist, red remains represented by dozens. Each transaction is thus logged as an archival event, providing another confirmation that the species exists, albeit barely. As the Argyle mine has now closed, the likelihood of a significant new supply is minimal. Dealers note that any fancy red diamond entering the market attracts immediate global attention. Museums, private collectors, and investment houses treat them as singular holdings, often kept off display. Ranked third, Imperial Jadeite, Myanmar's green treasure, reaching $3 million per carat. Jadeite is a pyroxene, sodium aluminum silicate, with a hardness of 6.5 to 7 and a density of 3.3 to 3.4. Its value is not in chemistry alone, but in the particular combination of chromium-induced green and translucency found in northern Myanmar. The finest material shows an intense, saturated hue, evenly distributed, with a texture so fine that light penetrates and diffuses softly through the structure. The stone's path into history began only in the 18th century. For millennia, Chinese culture has revered nephrite, which was used in rituals, art, and burial. Then in the late Qing dynasty, Burmese traders introduced jadeite from the Kachin Hills. Its brightness and clarity eclipsed nephrite in the eyes of the imperial court. The Qianlong Emperor's era marked the beginning of jadeite's ascent as the supreme jade. The term imperial jade became associated with specimens of pure, vibrant green, semi-transparent to translucent jade. These stones entered palace collections and, by extension, the broader culture of East Asia. Jadeite bangles and carvings became status symbols, family heirlooms, and ritual gifts, reflecting the high value placed on jade in ancient China. The stone carried connotations of virtue, prosperity, and protection, ensuring that demand extended far beyond elite circles. Geologically, Myanmar's deposits remain the sole primary source of fine jadeite. The mines of Hapakan, Longkin, and Tao Mau have supplied the global trade for more than 2 centuries. Rough jadeite is traded in large boulders, often coated with a weathered skin that conceals the interior quality. Dealers cut windows to reveal color, a practice recorded in gemological and trade archives. Scientific constants fix jadeite as NaAlSi 206 monoclinic, with indices of refraction 1.654 to 1.688. However, value depends on factors not captured by the formula, such as hue, translucency, texture, and freedom from cracks. Laboratories in Hong Kong and Geneva issue reports confirming the natural color and absence of polymer or dye impregnation, which significantly affects the price. The modern market has elevated Imperial Jadeite to extraordinary levels. In 2014, Sotheby's Hong Kong sold the Hutton Mdivani necklace, composed of 27 jadeite beads, for $27.4 million. Other auctions have documented bangles reaching more than $3 million per carat when calculated by weight. These prices rival, and sometimes surpass, ruby, sapphire, and emerald. Unlike most gemstones, jadeite is not primarily faceted. Instead, it is carved into cabochons, beads, and bangles. Cultural preference dictates form. A single bangle, cut from flawless jadeite of imperial quality, can represent the pinnacle of value because of the difficulty of finding large pieces of rough without fissures. Culturally, the significance continues. Across Chinese-speaking communities, jadeite remains a symbol of protection and continuity. Auction catalogs emphasize provenance, but the buyers often view ownership in terms of heritage as much as investment. No other gem straddles the divide between living tradition and modern record quite like jadeite. Ranked second, pink diamond, fancy vivid pink. Fancy vivid record above $2.6 million per carat. Pink diamonds exist within the same structure as all diamonds. Cubic carbon, hardness 10, specific gravity 3.52, refractive index 2.42. Their color arises from lattice distortion during crystal growth, where stress dislocates atomic planes and alters absorption. The result is pink, often unevenly distributed, visible as graining under magnification. Laboratory grading distinguishes between faint and fancy vivid, with the latter representing the strongest and rarest category. Historically, pink diamonds were documented in India's Golconda mines, but only sporadically. The Argyle mine in Western Australia defined the modern record. From the 1980s until its closure in 2020, Argyle supplied more than 90% of the world's pink diamonds. Even so, only a fraction were above 1 carat, and fewer still were graded fancy vivid. Each year, the Argyle Pink Tender presented a handful of such stones, treated as reference material for the category. Gemologically, pink diamonds show no chromophore element, such as chromium or boron. The color is entirely structural. Advanced spectroscopy reveals absorption features linked to deformation, distinguishing natural pinks from treated stones. Laboratories such as GIA issue certificates that detail the color grade, cut, clarity, and carat weight. Culturally, pink diamonds achieved prestige in the late 20th and early 21st centuries. They became markers of exclusivity, appearing in high jewelry collections and celebrity acquisitions. Their symbolic value is contemporary, not traditional. The market record is precise. The most famous is the Pink Star, a 59.60 carat fancy vivid pink diamond. Internally flawless, auctioned by Sotheby's Hong Kong in April 2017. The hammer price was $71.2 million, equivalent to more than $2.6 million per carat. This remains the highest per carat price for any pink diamond of its size and quality. Other notable entries include the Graf Pink, 24.78 carats fancy vivid pink, sold at Sotheby's Geneva in 2010 for $46 million, and the Williamson Pink, a more minor but historically significant stone from Tanzania, gifted to Queen Elizabeth II in 1947. Each is cataloged in gemological and auction records, accompanied by laboratory certificates and provenance details. The closing of Argyle in 2020 has intensified demand. With no primary replacement source, existing stones represent a finite supply. Dealers note that prices for certified fancy vivid pink diamonds have continued to rise, with private sales setting benchmarks that are not publicly recorded. Scientific constants anchor every entry. Hardness, 10. Refractive index, 2.42. Specific gravity, 3.52. Dispersion, 0.044. Cause of color, lattice distortion. These figures position pink diamonds firmly within the diamond species, while their market value is based on the rarity of color intensity. In first place, blue diamond, fancy vivid legends reaching $3.9 million per carat. Blue diamonds belong to the same species as all diamonds. Carbon in cubic crystal form, hardness 10, refractive index 2.42, dispersion 0.044. Their rarity stems from boron, a trace impurity that substitutes for atoms in the lattice. Boron absorbs red wavelengths, producing the visible blue. Unlike most diamonds, blue stones conduct electricity, a measurable property that confirms their identity. Historically, blue diamonds entered records through India's Golconda mines. The most famous is the Hope diamond, a 45.52-carat fancy deep blue, now housed in the Smithsonian Institution. Its provenance runs through 17th-century European quartz, sales, and eventually to a donation, making it both a scientific specimen and a cultural artifact. Modern production has shifted to South Africa's Cullinan mine, the source of many of the largest and finest blue diamonds documented in recent decades. Laboratory certificates from GIA and SSEF confirm fancy, vivid blue grades for stones that have entered auction catalogs and museum archives. The market recognizes their scarcity. The Blue Moon of Josephine, a 12.03-carat stone, sold in Geneva in 2015 for $48.5 million. The per-carat price exceeded $4 million, setting a benchmark at the time. A year later, Christie's Geneva presented the Oppenheimer Blue, a 14.62-carat fancy vivid blue, rectangular cut, accompanied by GIA certification. The final hammer price, $57.5 million. At $3.9 million per carat, it became the highest per-carat price ever recorded for a diamond of its size and grade. Blue diamonds are logged specimen by specimen. Auction catalogs list carat weight, cut, color grade, clarity, provenance, and laboratory report. Each transaction is an archival event. Unlike pink or red diamonds, which often weigh under 1 carat, blue diamonds have yielded larger specimens, further heightening their visibility. The gemological constants remain consistent. Hardness 10, specific gravity 3.52, conductivity present. Cause of color, boron. These features, measurable in laboratories, separate them from treated or synthetic stones. Advanced collectors demand certification of natural origin and fancy vivid grading, as even slight gray or violet modifiers lower the value. Culturally, blue diamonds hold symbolic roles in museums and collections, but their primary identity is economic. They represent the highest tier of gem pricing, with sales figures that surpass those of rubies, emeralds, or jadeite. The Oppenheimer Blue in 2016 and the Blue Moon in 2015 remain reference points cited in trade journals, gemological bulletins, and investment analyses. The closure of the Argyle mine in 2020 had a minimal impact on blue supply, as Argyle was not a significant source of blue. Cullinan continues to provide occasional specimens, but the volume remains extremely small. Each discovery, cut, and certification adds to a record that grows slowly, stone by stone. The record of these 15 gemstones is not closed. Each stone remains fixed in its own entry: weight, color, origin, auction result. Yet the market continues to add new lines. Mines still produce in small quantities, laboratories continue to certify, and collectors compete for what few specimens appear. From black opal and lightning ridge to the blue diamonds of Cullinan, The path of value is shaped by geology, confirmed by science, and recorded in catalogs. Cultural histories and market archives converge, showing that rarity is not a matter of belief, but of evidence. Documented discoveries, authenticated origins, and transparent transactions. The figures are striking, hundreds of thousands of dollars per carat, in some cases millions. But beyond numbers, what remains is the clarity of record. Each stone examined here has been cataloged, verified, and preserved in history. The ledger stands as it is today. Tomorrow another stone may enter it. For now, these are the 15 most expensive gemstones in the world.